The function f of x is graphed. What is its domain? So the way it's graphed right over here, we could assume that this is the entire function definition for f of x. So for example, if we say, well, what does f of x equal when x is equal to negative 9? Well, we go up here, we don't see it's graphed here. It's not defined for x equals negative 9 or x equals negative 8.5 or x equals negative 8. It's not defined for any of these values. It only starts getting defined at x equals negative 6. At x equals negative 6, f of x is equal to 5. And then it keeps getting defined. F of x is defined for x all the way from x equals negative 6 all the way to x equals 7. When x equals 7, f of x is equal to 5. You can take any x value between negative 6, including negative 6, and positive 7, including positive 7, and you just have to move up above that number wherever you are to find out what the value of the function is at that point. So the domain of this function definition, well, f of x is defined for any x that is greater than or equal to negative 6, or we could say negative 6 is less than or equal to x, which is less than or equal to 7. If x satisfies this condition right over here, the function is defined. So that's its domain. So let's check our answer. Let's do a few more of these. The function f of x is graphed. What is its domain? Well, exact similar argument. This function is not defined for x's negative 9, negative 8, all the way down, or all the way up, I should say, to negative 1. At negative 1, it starts getting defined. F of negative 1 is negative 5. So it's defined for negative 1 is less than or equal to x, and it's defined all the way up to x equals 7, including x equals 7. So this right over here, negative 1 is less than or equal to x is less than or equal to 7. The function is defined for any x that satisfies this double inequality right over here. Let's do a few more. The function f of x is graphed. What is its range? So now we're not thinking about the x's for which this function is defined. We're thinking about the set of y values. Where do all of the y values fall into? Well, let's see. The lowest possible y value, or the lowest possible value of f of x that we get here, looks like it's 0. The function never goes below 0. So f of x, so 0 is less than or equal to f of x. It does equal 0 right over here. F of negative 4 is 0. And then the highest y value, or the highest value that f of x obtains in this function definition is 8. F of 7 is 8. It never gets above 8, but it does equal 8 right over here at when x is equal to 7. So 0 is less than f of x, which is less than or equal to 8. So that's its range. Let's do a few more. This is kind of fun. The function f of x is graphed. What is its domain? So once again, this function is defined for negative 2. Negative 2 is less than or equal to x, which is less than or equal to 5. If you give me an x anywhere in between negative 2 and 5, I can look at this graph to see where the function is defined. F of negative 2 is negative 4. F of negative 1 is negative 3, so on and so forth. And I can even pick the values in between these integers. So negative 2 is less than or equal to x, which is less than or equal to 5.